For over a century, the Los Angeles Basin operated as a rigid, concrete grid built for high-mass vehicles. The result was a persistent trap of atmospheric pollution. But the pollution overhead is matched by extreme volatility on the ground. The region now suffers from weather whiplash. Prolonged droughts are interrupted by massive atmospheric rivers, dropping billions of gallons of water onto impermeable asphalt and overwhelming the city's outdated drainage. When the rains stop, those prolonged dry spells turn the surrounding wildlands into a tinderbox, creating a persistent fire threat right on the city's borders. The environment is shifting faster than traditional infrastructure can handle. Defending a rigid, concrete basin against these extremes is a losing battle. Part of the problem is the energy penalty of our current transit model. Maintaining 140 square miles of asphalt strictly to move 4,500-pound private vehicles is staggeringly inefficient. This massive power demand creates a strange paradox. During the middle of the day, California's grid actually generates more solar energy than it can use, forcing operators to dispose of gigawatts of clean power through a process called curtailment. This chart illustrates why curtailment happens. You can see the massive bell curve of solar production peaking in the middle of the day, while actual consumer energy demand stays relatively flat. That gap represents terawatt-hours of wasted energy. What if we captured that massive, discarded, gigawatt-scale solar surplus and weaponized it to terraform the entire basin? Utilizing that single wasted resource triggers a chain reaction that completely rewrites the city's transit, its local climate, and its ecology. The first domino to fall is a 500-mile expansion of the metro system, engineered to function as a smart load on the grid. Instead of pulling power during peak evening hours, the rail network uses massive kinetic flywheels to physically absorb and store that excess midday solar energy, deploying it as trains move through the day. Up in the sky layer, a network of 1,200 automated vertiports follows the same logic. Their megawatt charging banks act as industrial-scale batteries, powering regional air hops while balancing the grid. Down at the surface level, dedicated greenways host hyper-efficient, low-mass automated e-pods for last-mile transit, cutting energy consumption to a fraction of a kilowatt-hour. By separating mobility into this specific three-tiered electric mesh, the city renders the private car unnecessary, freeing up millions of square feet of land. That newly available land enables concrete alchemy. We rip up defunct massive freeways and replace them with deep subterranean reservoirs capable of holding 600,000 acre-feet of captured storm runoff. The surface above these reservoirs is then planted with deep-rooted tropical flora, relying heavily on the Ficus bengalensis, or banyan tree. These trees act as biological pumps. Their unique, high-tensile aerial root systems form vascular nodes that physically pull the captured stormwater up from the new subterranean reservoirs. As the water travels up, the trees sweat it out into the atmosphere through intense transpiration. This cycle acts as a natural air conditioner, lowering the surrounding ambient temperature by up to 10 degrees. Urban infrastructure has shifted from dead, heat-absorbing asphalt to a living biological system that actively slashes the city's cooling demands. This illustrates the Vascular Lift. We use the transit network's solar surplus to power massive pumps pushing water from city-level reservoirs uphill, supporting the assisted migration of climate-adapted forests across the San Gabriel and Santa Monica ranges. This initiates the biotic pump. Heavy transpiration from these new forests creates a massive zone of high inland humidity acting as a pressure shield. When the highly combustible Santa Ana winds roll in, they hit this moisture dome and are deflected. By directly linking solar power to hydrology, the city engineers a proactive atmospheric defense system that stops wildfires before they can spark. By 2076, transit networks, architecture, and dense tropical ecology exist in total symbiosis. The entire model shifts. Transit networks now function as the cardiovascular system of a living bioregion, distributing the water and energy required to sustain the urban forest. In this system, captured solar power pumps the water, grows the canopy, and dictates the local weather. Through aggressive solar integration and biomimetic engineering, we can rebuild our cities to heal themselves.